This podcast is brought to you by Kyoto Japan Automotive Group, a company which I've known personally for over 20 years, and your one-stop shop for tyres, batteries and auto parts. Visit their website at www.kyotojap.com for more details. Thanks for downloading the Mackay interview, and apologies for my voice. My guest on this podcast is Professor Francesco Pepe, Director of the University of Geneva Observatory. We cover a wide range of topics, including the evolution of the observatory, what use astronomy really serves, and how Geneva's contribution to the science of astronomy fits into the larger picture of research worldwide. I hope you enjoy the podcast. Hello, everyone. Today I'm reaching for the stars. I'm inviting you all on a visit to one of Geneva's best-kept secrets. I'm a guest of Professor Francesco Pepe, who is the director of the University of Geneva's Observatory, tucked away in the forest in the commune of Versoix in Geneva. Now, Professor Pepe is a distinguished scientist who started his academic career at the ETH, the ETH in Zurich. That's a well-known federal university in Switzerland where he did his PhD in infrared astronomy. He's extremely well published, steeped in numerous important research projects, as well as a dedicated teacher of students and a supervisor of doctoral students. Listeners, we're in the presence of a formidable intellect and, as you'll soon hear, a compelling and enthusiastic communicator. Welcome to the Mackay interview, Professor Pepe. Thanks for inviting me back to record this interview and to speak to our wider radio audience.
Hi, Michael. Yeah, nice to have you here.
It's good to be back again. Professor Pepe, Francesco, if I may, you're hidden away here in the woods, only 14 kilometers from Geneva, and within Sunday afternoon strolling distance to Geneva Airport and the French border. I live not far away and have driven past the entrance countless times, but until a few months ago, on a visit to meet you for the first time, never actually entered. It's a fascinating place. But what goes on here?
Yeah, that's the astronomy department. That's what we call the Geneva Observatory. We are here in the woods of Versoix, a little bit far away from the city for evident reasons, because we observe the sky. Actually, we used to observe the sky from here, but we observe the sky also from elsewhere, from better places. But here we have this astronomy department. So that's 180 people who do research in astronomy. And this is the biggest institute in Switzerland in astronomy.
In the whole of the country? Wow.
Yes.
Okay.
Yes.
That's fascinating. Now, I was surprised, pleasantly surprised, to learn from you of Geneva's long history with the heavens, its stars, and its planets. But please tell me the story again for the benefit of our listeners. I mean, the history goes back well over 250 years, doesn't it?
Yes, we just celebrated the 250 years of existence of the Geneva Observatory, which was born in 1772.
1772?
Yeah, so the 250...
But that would have been in the city, in the Ville de Genève, in those days, I guess.
In those days, it was in Geneva downtown, indeed. Yeah. There were different observatories built in Geneva, so there was not only one building, there were several during the lifetime, and only in 1966, it moved to Versoix.
So this building that we're in today?
Yes, this was built in 1966. At that time, it was still the Geneva Observatory, so an entity independent of the university until 1973. So this was born as the Geneva Observatory because of Mallet, of the first science
Mallet was a
professor. Yeah.
Professor Mallet.
Yeah. In 71, actually, he was nominated professor of the Academy of Geneva. At that time, it was the Academy.
And what year was that?
Sorry, 71, if I remember correctly. So 1771.
71, as long ago as that.
Yeah, that was the first science professorship in Geneva. And the observatory was born from his wish to have an observatory also in Switzerland. He actually participated in 1769 to a campaign to observe together with other scientists across Europe the transit of Venus in front of the Sun to measure distances in our solar system. So he participated to this international campaign, which was in Russia, and he had visited the St. Petersburg Observatory in Russia. He was fascinated by the instruments and the observatory itself. So when he came back, he proposed to build an observatory here.
So the relationship with the university goes back to roughly the 18th century.
Yeah, so that was the 18th century. So actually the start of the observatory was the relation with the university. But at that time, the Geneva Observatory was not part of the university. It was an independent entity. But Professor Mallet was science professor at the university, or became science professor at the university. So in 1772, he proposed to build an observatory. And the Magnifique Conseil at that time, so the Grand Conseil of aujourd'hui, decided after long discussions that yes, he would be allowed to build the observatory, but at one condition: he would have to pay for it. So fortunately, he had some money from his family, and he paid the observatory.
Doesn't it? Oh, gosh, that's fascinating. So tell me, astronomy, Francesco, is mysterious and awe-inspiring. These are my words. But why is it important and useful? Now, after all, you've dedicated your professional life to it, so it must be important. But other than to enthuse non-specialists, non-scientists like me, most of us listening now, why is astronomy important and useful?
This is a question that I hear many, many times. So people ask me this question: what it is good for? Why it's useful? Let's be frank. This is a philosophical question.
Yes.
Okay.
Yes.
This goes back. I mean, why is art useful? Is art useful?
Is it useful?
Yeah.
That's right.
Or why is it useful to have a big car if you want just to go from A to B? Do you need a car which costs 200,000 euros? So, I mean, the question of being useful is really, really very tricky.
Well, maybe I chose the wrong word.
Yeah. No.
Yeah,
but
maybe
it's not. No, it was not the wrong word. A word. I just wanted to point out that it depends a little bit of what people understand by or mean by the word useful, to be useful. I would say that the question can be answered in many different ways. So first of all, astronomy is a fundamental research. Okay, we do fundamental research. We do not fundamental research in French. Recherche. It's very similar. Okay, it's to search for something, to search for answers. Sometimes you don't find it. Okay, but it's actually the action to search for answers that is important. Sometimes to find an answer, sometimes not. That makes the research. And why is this important? Because if mankind was not able to do research in all the areas, we would still be animals.
Absolutely.
Okay?
I understand
so we would
that.
act like animals. So what made mankind progress is actually this idea of asking questions and trying to answer these questions.
Curiosity.
That makes the difference, I would say, and this makes mankind progress. Now, this remains very philosophical, but you may ask also some practical usefulness, and that's another aspect. I go to one extreme to the other. I would say that there are practical usefulnesses that uses that you understanding things is always useful, and that I think nobody could contradict. But look, if you asked Maxwell who wrote equations about electrodynamics about 200 years ago, a little bit less. Okay, so he wrote it. It described electrodynamic. So what is electricity? What is magnetism? What are waves? He described this in equations and a very, very complicated mathematical construction.
200 years ago.
200 years ago, a little bit less. If you asked Maxwell, what is this good for? He would not have any answer at that moment. But today, these micros we are using, or a remote control, or a car, or a rocket, or whatever, a coffee machine, whatever you use, it's based on electromagnetism, electricity, magnetism, whatever you want. And all this would not work if we would not understand it and if we would not be able to describe it.
Thanks to Maxwell.
Thanks to Maxwell.
My God.
Okay, but 200 years ago, it would not have been able to tell you what it is good for. Impossible. Right?
Now, Francesco, let me ask you another question. We're going to step outside of this building a little bit. I just want to ask you, astronomy in Geneva, is it part of a bigger Swiss or even international jigsaw? I mean, place what goes on here in a wider context of what you're doing with colleagues in other parts of the country or in other parts of Europe or in other parts of the world.
Yes, so it's at all these levels you mentioned, okay, from local to international and worldwide. As other domains of fundamental research, there are activities going on elsewhere in the world. There is some kind of, I would say, constructive competition because everybody wants to try to understand something new, find new results, and so on. The same in astronomy. We have the advantage in astronomy that this is a domain that also people who didn't do any science can somehow understand or feel to some extent because it's very visual, it's very nice. But still, it remains a domain of fundamental research. So we have collaborations. That's, I would say, the key word. We have projects. Collaborations and projects today, they become more complex, bigger, more expensive. You can't do that at local level only, not anymore. So you start collaborating with people in Switzerland. We're using federal funding, sometimes, but very rarely here in Switzerland, private funding. Most of the funding comes from the universities and from the Swiss National Science Foundation. So you build up common collaborations or projects to measure, to build a new instrument, or to investigate a question. And then you try to be strong at national level, but sometimes this is not sufficient. So you go for international collaborations. You work together with the European Southern Observatory, which is an agency that, let's say, coordinates the effort of several European countries to observe in the Southern Hemisphere. So we have observatories in the Southern Hemisphere, but we have also partnerships with American, Australian, Japanese groups. So it's a really global effort which is done here, more and more, actually.
So from this small place, you have really, as you said, an international network.
Yeah, and we are also, I think we are not only involved in these international networks, we have also sometimes leadership in them because of some domains in which we are extraordinarily strong and with the colleagues. So we also lead several projects.
And the first time I met you, you said to me that, in fact, I think you even showed it to me, that there's a piece of equipment here that is the only piece that exists in the world, and people come here to use that particular platform or piece of equipment, if I put it in my simple language.
Yeah, so it's a little bit a different situation. It's not a piece of equipment which is here. It's an equipment, a spectrograph, so a machine to analyze the light, to decompose white light in all its colors, like a rainbow, which is especially built to find and characterize extrasolar planets. So planets around other stars, like our sun, but other suns, other stars. So we are very strong in this domain, and we are very strong in building instruments to do that. So that's one of our specialities. And the instrument I had shown you or mentioned is called Espresso. This is espresso,
like coffee.
Espresso, like coffee. Yeah, okay. Sorry for that.
An Italian connection. Okay.
Yeah, it was also. I mean, it was a collaboration between Italy, Switzerland, Spain, Portugal.
It sounds like a great name.
So it was a common, and we wanted to do it fast. So espresso as well.
I see.
And this spectrograph is the most precise in the world.
Really?
Yeah, that's of its kind.
Yeah.
There is no other that is more precise than that. So people come to us and want to know how to build that and ask for collaborations on other projects.
Bravo,
yes.
Geneva. My guest today is Professor Francesco Pepe, and I'm his guest at the University of Geneva's Observatory in Versoix, just a short distance from the city, and we're talking about astronomy, the stars, the planets, and the heavens. Francesco, in your academic career, what have been the major advances in the science of astronomy that have had the biggest impact, and why have they had the biggest impact?
Yes, so there are several advances, and I mean, like for example,
pick one or two that are really significant in your career.
In my career, I would say that there are two. One is very close to what I do, and the other is more general, which is linked to the theory of the Big Bang, of the expansion of the universe. So these were there. I would say that to measure the cosmic microwave background, so the residual, what is left from this Big Bang, from the original explosion, about 14 billion years ago. So to 14 billion
years ago. Okay, because it's a big number.
It's a big number. Okay. It's a 14 with 9 zeros.
9 zeros, exactly.
Years.
Yeah.
Okay, that's the age of the universe. Yeah. Okay, to measure, to detect this background, that's one of the major discoveries, I would say. The other one is the fact to demonstrate for the first time in the history of mankind that our sun is not the only star to have planets. And this has been done by Michel Mayor and Didier Queloz, two professors from the Geneva Observatory, who in 1995 discovered for the first exoplanet, so the first planet around another star. If I have to mention two, I will mention these two, but there are many other discoveries.
And are these by any chance the same people who got the Nobel Prize, or are they different people?
These are so the two people I mentioned, Didier Queloz and Michel Mayor. Michel Mayor was professor here, and Didier Queloz was his PhD student at that time, and they did the discovery together. So they both got the Nobel Prize for the same reason, 2019. Yeah, for the discovery of the first extrasolar planet.
My gosh. Now, I'm just going to move on a little bit more quickly because I've got so many more questions to ask you. But, since I met you, and I've now been around this place twice, thanks to you, I've learned so many new words, names and acronyms. It's a bit like anything else in the United Nations. There's always acronyms and abbreviations. GAIA, EUCLID, CHEOPS, just to name three of them. Tell me more about these projects and why we ought to know about them.
Yeah, so these are actually only three of these many acronyms I mentioned before, Espresso, but I could mention also Athena or many other projects we are doing here. So these are all names of projects. In that specific case, satellites.
And they're ongoing, or they started and finished? I mean, how does it work?
So the three you mentioned, they are all ongoing. At different stages, but they are all ongoing. There are many other projects, past projects, there are future projects or instruments that are being built or just operating. So they are at different levels.
And these three, what do they actually do? GAIA, EUCLID, and CHEOPS. What are they for? What
GAIA, for example, GAIA is a European satellite which was launched now already, I don't remember, 6, 7, 8 years ago, so probably more, that is actually observing our neighborhood, is measuring the position and the speed of all the stars around us. So it's making a really detailed map of our neighborhood, if you want, to a detail that has never been done before. So this makes us understand and know very well billions of stars in our neighborhood. Euclid is at the other end. Euclid is looking for dark matter. It's Euclid. Why it's called Euclid is because it wants to understand the geometry of the universe. So it's making a map of the whole universe, the visible universe, with a bigger telescope. It's also a satellite so with a bigger telescope. And here we want to understand where this hidden matter, which we call dark matter, is located, how it's distributed, again to understand better the formation and the evolution of our universe and the forces that make our universe.
And just to clarify, sorry if it sounds like a silly question, Francesco, but when you say the universe, do you mean our galaxy or whatever else is out there that we just don't know about? What is the...
Yeah, the universe is everything we know.
Everything we know.
We can know. Okay,
yeah.
It's
okay
because you can. There are theories that talk about or say, we claim that there are parallel universes and so on. But these are speculations.
Right.
What we see here, okay, is everything what is we can observe and we understand to some extent. We call it universe.
Right.
So it's everything.
Okay.
Everything. The universe is made of galaxies, but there are hundreds of billions of galaxies.
Hundreds of billions.
Yeah, of galaxies.
I mean, these numbers are just impossible to understand.
Every galaxy contains hundreds of billions of stars. And every star has at least, or as we know today, probably every star has at least one planet or more. So if you compute the number of stars in the universe, that's something like a 4 with 22 zeros.
To the power of 22.
Okay?
Yeah.
That's the number of stars in the universe, what we call universe. So we cannot observe all of them because some are too far away or there is gas and dust hiding them. But let's say everything what contains all this we call universe.
Okay, let's come back down to Earth.
So
again.
Euclid is observing that. It's also a European satellite. And then,
I forgot Cheops. Yes, you were going to say.
Cheops.
Cheops.
This is an important one because this is the first scientific satellite mission led by Switzerland.
I see. Okay.
Yeah.
Okay.
And we participated here to Euclid. We built components of these two satellites, of Euclid and Cheops, as the Department of Astronomy. Other institutes in Switzerland contributed to that.
So you make a physical contribution, not just an intellectual contribution, but a physical contribution.
Yeah, not only physical, also in terms of software, in terms of testing.
Yeah.
So we built and participated to this project, to the construction of these satellites, and we are now also participating to the scientific exploitation of them. And Cheops is, as I said, the first Swiss-led scientific mission. And here the goal is a different one, is to observe exoplanets. And
so what's an exoplanet? You used that word before, but I didn't understand that.
That's a planet which orbits another star. Okay, star, our sun is a star.
Yes.
Our sun has 8 planets orbiting around the sun.
Which is
one of
Jupiter,
them is Jupiter and the Earth.
Yeah.
The Earth is one of them. Well, since 1995, we know that other stars have also planets. They are farther away, so they appear to us like small dots on the sky, these stars, because they are much farther away than our sun. So they're very small. We see them at night. These are stars like our sun, and they have also planets. they are called exoplanets.
I see.
And Cheops observes known exoplanets and measures their size. So this satellite is able to measure the size of other planets outside our solar system and to determine whether they are bigger than our Earth or even bigger than Jupiter or smaller and so on. So we can measure very precisely the size of planets.
I see. So just coming down from the heavens back down to Earth, we talked about the southern hemisphere before. Quite often in conversations with you and colleagues of yours, Chile and the Andes mountains feature often. Why is that? What's going on in Chile and the Andes mountains?
Yeah, that's a question I ask visitors. I say, why do astronomers build observatories in the desert and on mountains? And there is an immediate answer to that, but not everybody thinks that this immediate answer is that to observe the sky, we need a clear sky. So where can you find clear sky? It's in places where it never rains. So you go to deserts. Now, why on mountains? Because on mountains, you don't have water vapor, so fog or just, sometimes in summertime, the sky is blue and clear, but it's light blue. It's because of the moisture in the atmosphere, so it's not as clear and transparent than it could be. So you go on the top of mountains in the desert to have the clearest possible sky. And why in Chile? Why in the southern hemisphere? Is because Europe is located in the northern hemisphere. So when you observe the sky, you will only see the northern sky. If you want to see stars in the southern sky, you have to go to the southern hemisphere.
Yeah.
So very different countries in Europe created this European Southern Observatory and built together an observatory in the southern hemisphere to observe the southern sky.
That makes sense. I understand.
And Switzerland joined this organization in 1980, and we are part of ESO, the European Southern Observatory, and by this we have access to big telescopes in the Southern Observatory.
I see. I've got a couple more questions for you, Francesco. Taxpayers' money helps to fund what you do. Public engagement is very important to you. Recently, you received a group of visitors from the British Swiss Chamber of Commerce. I had the privilege of being part of that group. Tell me about how you explain what you do to the local public in the Geneva region, and also then spend a little time, just tell me to what extent the private sector is involved in the funding of what you do here. Just give me some examples, please.
So what we do here in public outreach, so just let's recall us that the Geneva University has three missions actually: teaching, research, and public outreach. They call it service à la cité.
Yeah.
Services to the population.
The local population, yeah.
So we are active in the three of them, and astronomy is actually really very well adapted to do public outreach because you have something to show. People are interested in what they see. There is an aesthetism. It's beautiful.
I can testify to that.
Yeah. So that's, I would say, we have a privileged position here, but also a responsibility. We have to bring what we know and the privilege we have to the population. And so, yes, there is this, and we do a lot of activities of public outreach, going from combining science with art, from welcoming visitors here and showing what you are doing in terms of research, but also 3D or documentary movies. We are trying to build now a new mediation center, a new public outreach center to do workshops with kids. There is, for example, a comics book that talks about
for my grandchildren.
That talks about astronomy it's a story about astronomy, but also also it teaches some fundamental aspects of astronomy to the kids.
Very
so
important.
there is really a lot we do, and we want to do more if possible.
Well, fantastic and fascinating. Just looking to the future in a different kind of way, is it relatively simple for you to get young people just starting their university studies to take up astronomy or related science subjects, or do you have to work hard to attract them into astronomy?
No, I think that we don't have any problem in attracting people. What we have to do sometimes is a little bit of being selective, because astronomy is
not... Of the people or the project, or both?
No, on the people.
The people,
okay,
yeah.
Because people have to understand, young people have to understand, if they want to become astronomers, that they have to be, before being an astronomer, they have to be mathematicians, physicists, to be astronomers.
So they have to have a good basis, good basis.
It's mandatory. Okay, so
yeah.
Astronomy is not about knowing all the constellations by heart. This is not professional astronomy. Professional astronomy is doing astrophysics, understanding the physics of what you observe, going to cosmology, the origin of the universe. So this is mathematics, this is physics, and then it becomes astronomy.
So astronomy is a graduate study or a postdoctoral study, is it?
There are all level, but there is no bachelor in astronomy. So you do a bachelor in physics,
right.
Then you do a master in astrophysics. That's actually the only place in Switzerland where you can do a master in astrophysics.
Here, this is the only
place?
place?
Yeah, this is the only place, the Geneva, so the Department of Astronomy of the Geneva University. Yeah. And then, from there, if you want to stay in research, you can do a doctoral study, PhD. So you can become doctor, and then you start, maybe or maybe not, because there are many other opportunities. You can start your academic career as a postdoc, and then further as a senior researcher, and so on, and become professor if you want, if you can, and if you want.
I see.
But it's really important to understand that it's, I think many people are attracted by astronomy, but it requires really mastering also mathematics and physics. So you need both.
So it's good for any young people listening in that they need to do their groundwork and their homework thoroughly, and then listen to the professor.
But this is true for any domain.
Yes, that's true. That's true. Last question, an obvious question. What are you working on currently? What's new that's going on that the listeners would like to hear about?
Yeah, so there are, as I told you, there are many projects.
Is it invidious to ask you if you have a favorite?
Yeah, I mean, I can't talk about my favorite because it's the most immediate and it's in the domain I'm directly working in.
Please do.
And that's a small spectrograph called Ristretto.
So that's coffee again.
Yeah, coffee again. Because we decided that actually the PI is the principal investigator is a colleague of mine, Christoph Lovis. Professor Lovis, who said, it would be nice if we had a smaller version of espresso. That's why he had the idea to call it ristretto. Yeah. Not to observe many stars, but to observe the stars closest to us who are known to have an exoplanet, again, exoplanets, and this time not to measure their mass or their diameter, but to look at their atmosphere and maybe try to detect oxygen on the atmosphere of exoplanets. So that's, I would say, the most, for me, the most immediate and the most challenging, but also extremely interesting project, because we might be possible within a couple of years to find oxygen on a habitable planet around another star. That's the main goal of this project, but there are so many others. So
that's work in progress.
That's work in progress.
Could you make me a promise? Invite me back when you've discovered the answer, and we can talk about what you found.
Yeah, that would be great. Yeah. I mean, I will invite you.
Thank you.
For sure.
Francesco, it's been really illuminating. I've learned a lot, as I knew I would, but it's fascinating just listening to you. My guest today has been Professor Francesco Pepe, Director of the Versoix Geneva Observatory at the University of Geneva. Many thanks, Francesco.
Thank you.
Thanks for listening to the Mackay Interview podcast, brought to you by Kyoto Japan Automotive Group, a company which I've known personally for over 20 years, and your one-stop shop for tyres, batteries and auto parts. Visit their website at www.kyotojap.com for more details. And you can find more podcasts on Anchor FM. Just Google Mackay Interview Anchor FM. Thanks again for listening.